Alright guys, in this video we're going to talk about surface area of prisms and cylinders. Okay, so we need to know a couple vocabulary words. First off, we have lateral faces. This is parallelograms formed by connecting corresponding vertices of the bases. Okay, so like this right here, this face is a lateral face. Lateral edges are going to be the edges that are on either side of one of those faces. Okay, and then the third one is a prism. That's a polyhedron with two congruent parallel bases. All right, so this base down here and this one up here are congruent, they're the same, and they're parallel. We're going to name each of these. The names are already here, but this is a rectangular prism because the bottom bases, the top base are the same. Okay, and they make rectangles. Triangular prism. Again, here the base is actually this back one and this front one. Okay, so you could flip it on its side, is kind of how it's oriented now. If you flip it on its side, then the base is on the top and bottom, but currently it's not on the top and bottom. Example 3, this is a hexagonal prism. Again, here's the first base, here's the second base. Okay, so if you were to take this and kind of orient it so that's on the bottom, then we have a top and a bottom base like that. And then the fourth example is a pentagonal prism. 5 sides, 1, 2, 3, 4, 5. Here's the top base, bottom base. This one is oriented the correct way. A right prism is each lateral edge is perpendicular to both bases. So you can see I drew in the right angles there. And then an oblique prism, this one, they're not right angles. Okay, this is not a right angle right there, and neither is this. So I cannot put those in. That's oblique, an oblique prism. Surface area versus lateral area. Surface area is all the sides and the top and the bottom if you find the area of each and add them all together. That's what the sum means, the sum of all the areas of all of its faces. And then the lateral area is the surface area minus the top and bottom base. Okay, it does not include the bases, just the lateral faces. This one says, how could we find the surface area of this prism? So this is a net, right? If you fold this back together, it makes a hexagonal prism. There's 6 sides here. And also think if you fold, it's like this side's already touching, but then this side would connect with this one here, and so on. This one with up here. So the perimeter of this hexagon, the distance all the way around here, should be the same as this length. Right, so we're going to say we want the perimeter times, like that would be the height. So I'm going to say perimeter times the height, and that's going to be all of our, that'd be like this area of this rectangle right here. And I'm going to add that to both of the bases. I'm just going to say the area of the base times 2, or 2b. 2b plus the perimeter times the height should give us the whole surface area of that prism. And you can see right here in this one, it absolutely does. Surface area equals 2 times the base plus the perimeter times the height. And you can kind of see the examples in the figures to the right. Okay, so let's work with this now. In this first one, again, we have 2 times the base plus the perimeter times the height. So in this one, our base is going to be 5 times 10. It's a rectangle. 5 times 10. 5 times 10 is the base. We want 2 of those. So 2 times the base plus the perimeter of that. Well, the perimeter of this base, we have 10 plus 5 plus 10 plus 5. That's 10 and 10 is 20. And then 5 and 5 is another 10. 20 plus 10 is 30 for the perimeter. And the height of this is 6. So here 2 times 5 times 10 is 100, plus 30 times 6 is 180, and if you put those together, 100 plus 180 is 280. And this is what, inches, so inches squared since we're talking about area. Example 2, this one's a little bit trickier. The perimeter of this hexagon is going to be, since it's regular, the tick marks indicate that it's regular, we're going to do 4 plus 4 plus 4, 6 times. 4 times 6 will be the perimeter. So off to the side here, I'm going to say P equals 4 times 6, which is 24. So we need the perimeter. We also need the height. We know the height in this one is H. Here's 8, I should say. Okay, because if you were to stand it up on its end, the 8 would be its height. And then we also need the area of one of the bases. Okay, and you can see I drew out this hexagon over here because to find the area of a base, remember area of these regular polygons from our last chapter, area is 1/2 the apothem. That's this right or perpendicular part coming out from the center to the edge. The apothem times the perimeter. So 1/2 A times P. Well, we already know the perimeter was 24, so I can say area of this is going to be 1/2 A, we still need, times 24. And to find the A, if this is 4, then each of these sides are going to be 2 and 2. Okay, to figure out this one, you know the central angle. The central angle of this, we're going to do 360 divided by the number of sides, which is 6. 360 divided by 6 is 60. And that makes this a 30, 60, 90 right triangle. Okay. And if you remember our right triangle rules, if this is 2, then this is also 4. Okay, and this would be 2 square roots of 3 for the apothem. So we're going to do 2 square roots of 3 right here. That's the area of one of the bases. We want 2 of those. Okay, so let's put this all together. If we have our formula, which is 2b plus the perimeter times the height, 2 times the area of one of our bases, well, 2 times 1/2, that's going to cancel. So we're just left with the inside 2 square roots of 3 times 24, plus the perimeter, which is also 24, times the height, 8. Okay, in the calculator, 2 square roots of 3, let's see, 2 square roots of 3 times 24. I'm going to round this a little bit. We're going to do 83.14 plus 24 times 8 is 192. So 83.14 plus 192 is 275.14. So 275.14 square feet is the area, the surface area of this polyhedron. Oops, I think I skipped a couple. Let me scroll down. There they are. We'll extend that a little bit. Okay, number 3 now is going to be a pentagonal prism. So very similar to the last one. We're still going to do 2 times the base, 2 times the area of the base, plus the perimeter times its height. And we need to know a few things here. Again, if I take this pentagon, these are a little harder to draw. That's not too bad. Okay. And I take this triangle, which is right like that. Let me make that a little better. We need to figure out the apothem again for this, for the area of the base. So again, we want to do 360 divided by 5, number of sides, to figure out the central angle. Okay, and 360 divided by 5 is 72. 72 divided by 2 is 36. And that's going to be this angle right here is 36. This is a right angle. We'll probably have to use trig to help us figure this part out. This is 6. So to find the apothem, I have, compared to this angle, I have the adjacent side and the hypotenuse. So that's going to be cosine. Cosine of 36 equals the apothem A, I'll call it, over 6. It's an A, not a 9. Okay, So if I multiply both sides by 6, then that gives me 6 cosine of 36. 6 cosine of 36 equals A. And 6 cosine of 36 is 4.85. We'll round a little bit. 4.85. 4.85 is the apothem. So the area of one of the bases, we could say, is going to be, so this is the apothem. I guess, sorry, we also need this length right here, and that would be sine. So the same thing, except now it's going to be 6 sine. I'm skipping a little step, but I just multiply by 6. 6 sine of 36 is going to equal, I'll call it x, maybe. So pull up 6 sine, I'm putting the calculator, is 3.53. And that makes sense compared to our picture, 3.53, and then there's 2 of those here, so if I double this, 2 times 3.53 is, I think, 7.06 times 3.53, yeah, 7.06. This is a little bit of a tougher problem. So the perimeter, since that's one of these sides, the perimeter is going to be 5 of those. 5 times 7.06, I believe, is 35.3. Times 35.3, it sure is. Okay, so then the area of one of the bases, maybe I'll come over here and do the area of a base, is going to be 1/2 times the apothem times the perimeter. So 1/2 times my A, which I found up here, is 4.85, times the perimeter, 35.3. If I put that in the calculator, 1/2 of 4.85 times 35.3 is 85.60. So let's call it 85.6. That's the area of one base. So we're going to do 2 times the area of one of those bases, 85.6, plus the perimeter. Again, that's the 35.3 .3 number, and then times the height. In this case, our height is 9. All right. So if I put this all together, 2 times 85.6 gives me 171.2 plus 35.3 times 9 is 317.7. Add that to the 171.2 from over here, and altogether this is 488.9 feet squared, or square feet. Some of these regular polygon ones are a little bit more involved. I'll show you this next one. It should be a little bit simpler. Okay, here we have a triangular base here and here. So if you remember, the area of a triangle is 1/2 base times height. And it looks like, actually, this is a regular triangle. So we can figure that out using our regular triangle formula, which I believe is 1/2. Here, hold on a second. Okay, actually the area of a triangle is sides squared, so 7 squared, square root of 3 divided by 4. Okay, and so to figure this one out, that's going to be 49 square root of 3 over 4. And that is the area of one of the bases. So then we also need to know the perimeter. That's 7 plus 7 plus 7, which is 21, 7 times 3. So P equals 21. Okay, the height here is going to be 5. If you flip this on one of its bases, the height is 5. H equals 5. So I think that's everything we need to know. We need the formula 2 times the base plus the perimeter, which is 21 times 5. And our base is going to be 2 times 49 square roots of 3 over 4 plus 21 times 5 is 105. And we can do this right here. 2 times 49 square roots of 3 over 4. Think of it like this. This 2 and this 4, that'd become a 1. This would become a 2. So really it's like 49 times the square root of 3. Hit enter, divide by 2 now, and you get 42.444 plus 105. If I add that together, that's 147.44. And that's square meters is the area. Oops. Is the area of this triangular prism. All right, last one here is going to be the surface area of the cylinder. Okay, so this one, the perimeter is actually going to be the same thing as the circumference. So P in this case is going to equal C, or circumference, which if you remember, the circumference of a circle is calculated by doing either pi d or 2 pi r. Since we have a radius, I'll use 2 pi r. So in our case, C is going to be 2 times 2, or 4 pi. All right. And then that's the perimeter. The height here is going to be 8. We also need to know the area of one of the bases, and the area of a circle is pi r squared. So in this case, the base, if I replace r with 2, 2 squared is 4, so that's 4 pi. So now the formula 2b plus the perimeter times the height is going to be 2 times our base, which is 4 pi. Oops, sorry about that. Plus p is 4 pi. That's the same thing as our circumference. 4 pi times our height of 8. So 2 times 4, I bet we can leave this in terms of pi. 2 times 4 is 8 pi. Plus 4 pi times 8. 4 times 8 is 32 pi. 8 pi plus 42 pi is actually 40 pi. And let's say this is in feet, so this would be 40 pi square feet. If you want a decimal, you can do 40 times pi, and that's 125.66 square feet. Okay, and that is how to find the surface area of prisms and cylinders.